Hi, good morning, everyone. In the last class, we have discussed about the Rutherford alpha ray scattering experiment. So, this Rutherford alpha ray scattering experiment, with the help of this one, we can come to know the discovery of nucleus. So, in this experiment, in the last class, we already discussed about that. There are three parts: procedure, observation, and the conclusion. Right. So, in the procedure, we had source of alpha ray, slide, right, gold file, and ZNS screen. So source will provide us a alpha rays, and slide it will make the beam of light to travel in a single direction. And the gold file is consists of matter or else atom, and the ZNS screen is a transparent screen which helps us to identify what all the experiment is taking place inside the thing, and one we can observe what is the different deflections are taking place, right? And in the observation what we saw is, this is about the procedure, and in the observation what we saw is, most of the alpha ray are passing through the gold foil. Some of the alpha ray are deflecting by making a small angle, and few of the alpha ray are bouncing back, right? So what will be the conclusion drawn from these three type of observation is nothing but the rays which are passing through the gold file, where they indicates most of the space present in atom is empty, right? The second point is nothing but those rays which are deflecting by making a small angle, they indicates there is a presence of proton. And finally, those rays which are bouncing back, they indicates, right, there is a presence of nucleus at the center, and which is very rigid. So now coming to the drawbacks, it has two drawbacks. Drawback means what are the things which couldn't be explained by this Rutherford alpha ray scattering. So the first drawback is, with this experiment couldn't explain about the what stability of atom. Stability of atom. That means this Rutherford alpha ray scattering experiment failed to explain stability of atom. That means when the atom will be stable. This theory couldn't explain. First drawback, and the second drawback is nothing but it failed to explain the chemical bond formation. It failed to explain, or it's also failed to it fails to explain chemical bond formation. Failed to explain chemical bond formation, right? Stability of atom it couldn't explain, and finally the chemical bond formation also not explained by, or couldn't explain by this Rutherford alpha ray scattering. So this is all about the Rutherford alpha ray scattering. So you go through it, definitely you will come to know of about Rutherford alpha ray scattering. So the next very important part of this chapter is nothing but what? Bohr's atomic theory, right? So different scientists will explain in their different views. So that is what we see, the different atomic models in this what chapter. Bohr's atomic theory. Very important for 3 marks. Definite question will be cancelled, right? With respect to Bohr's atomic theory, or Bohr's atomic model, or Bohr's theory, one we can say, definitely we will be having 2 or 3 mark question in our examination. So his consideration and his assumptions were different from Thomson and the Rutherford. and it is most perfect theory one we can say. So till now we just follow this theory, right? So say dear student, here the points are very important, right? He explained everything about the atom, right? So how the electron, what is the electron revolving, where and what are the different cells, subshells, everything he has explained about the what until electron filling rule also during what introduction classes and all, starting online classes, I have explained about the Bohr's atomic model, right? So, basic classes when I took, these concepts were already complete, right? So then also it is with your sequence of what syllabus. So thus the next part after Rutherford is nothing but what Bohr's theory or Bohr's atomic theory. Electron always revolve around first point. Electrons always revolve around the nucleus. Electron always revolve around the nucleus in a circular path, right? In circular path. First consideration with respect to Bohr is nothing but first he explained about the electron. Electron always revolve around the nucleus in a circular path, right? Like this. There must be a nucleus and always the electron revolve in a circular path. Each orbit is associated with some amount of energy is called energy levels. Each orbital, see, if it is a nucleus, then definitely we will be having some orbits, right? Different orbits. And this circle is nothing but, circular path is nothing but orbit one we can say. So we have in some atoms we have one circular path. In some other elements we have 2, 3, 4. That means it depends on the number of electrons. If the number of electrons are more, then the cells always will be extended, right? So more cell we will get. So in the same manner, if we see the next point is each and every path, I mean orbit is associated with its different energy. That is nothing but the energy level. So according to him, the next point, second point is uh, each orbit associated with the different energy, right? Different energies. That means energy level will be different from one circular path to another circular path. That means I will clear you the electron present here in this orbit and the electron present in this orbit, or else the electron present in this orbit will be having different energy. That is nothing but the energy levels when we say, right? Or else we can see 1s is having 1s in orbit of 1s, whatever the electron we have, that is having a lower energy as compared to 2s, as compared to 3s. Like this one we can decide. So this is about the second point. And the third point, the energy level are represented by see, energy levels are represented by, third point, these energy levels are represented by n is equal to 1, n is equal to 2, n is equal to 3, and n is equal to 4, right? With numbers, and by with letters, these energy levels can be called as K, L, M, and N. That means the second point was what? Each and every orbit has different energy, that is called energy levels, and these energy levels are represented with number by 1, 2, 3, 4, with letters by K, L, M, and N, right? While electron revolving in a particular orbit, electron neither gain energy nor loses energy. Very important. See dear student, if the electron is revolving in its same orbit, then it will not undergo into the loss of energy or else gain of energy. The energy remains same. That means stationary. So when it changes, we will see later. But whenever the electron is revolving in its own orbit, then definitely neither it gains the energy nor loses the energy. That is the thing. That means that is the fourth point. While electron revolving in its particular path, I mean in its own orbit, then definitely electron will not lose energy or else it will not gain extra energy, right? And coming to the next point, the energy of electron changes, right? So when it's revolving in its same path, definitely it will not change its energy. When it changes means when the electron jumps from higher to lower or lower to higher, like this. If electron jumps from lower energy to higher energy or else higher energy to lower energy, then only energy difference come into the existence. Until and unless electron is revolving in its own particular orbit, then definitely it will not loses the energy. When it loses energy is nothing but when it moves from its own leaving its own orbit to other orbit. When it does that thing, then definitely what happens, the energy difference will come. As the n value increases, the size and the energy of electron also increases, as we already know. As the n value, that means n value increases. If n value is 1 and next n value becomes 2, then definitely if we compare n value of one electron and second n value electron, then its size and energy is different, right? And finally, if we see when electron jumps from lower energy to higher energy, see, when the electron jumps from lower energy to higher energy like this, or else you can show like this, higher energy, then the absorption takes place. Whenever the electron gains energy, applied energy or heat or else sunlight, anything you can take. Whenever the gain takes place, then electron jumps from lower energy to what? Higher energy, right? It is called absorbed or absorption, one we can say. And next point, when electron jumps from higher energy to lower energy level, then the energy is emitted. That means loss. Electron, whenever the higher energy electron bounce back to the lower energy, then definitely when it happens, when there is a loss of energy, very important. Whenever the loss takes place, then electron jumps from higher to lower. Whenever the gain of energy takes place, the electron jumps from lower energy level to what? Higher energy level. So this is what about the Bohr's atomic model. I repeat, dear student, the first point is nothing but electron always revolve around the nucleus in a circular path. Each orbit is associated with amount of energy is called as energy level. Right? Third point. Third point is the energy levels are represented with number by 1, 2, n is equal to 1, 2, 3, 4, etc. with the letter K, L, M and N. While electron revolve in its particular path, it neither gains energy nor loses energy. When it gains or loses means when it jumps from higher to lower or lower to higher energy. And then as the n value increases, the size and energy of electron also increases or decreases. It depends. And when electron jumps from lower level to lower energy level to a higher energy level, then definitely when it does this thing, that means whenever the gain of energy takes place in it, right? So when the electron jumps from higher energy to lower energy, that means opposite, higher energy to lower energy. Whenever a electron loses its energy, then definitely what happens is it emits, or that process is called as emission. So this is all about Bohr theory. Again, in the tomorrow's class, we will have a little bit class on this, and next we will continue the same concept. Right? Thank you.